So absolute value inequalities is the topic that we are working on now. We have two examples on the board with a clear indication of how to write down different things here. First thing that I will highlight here, absolute expression isolated as x absolute greater than 2. What does that mean? That means whenever you are working on the absolute value which is greater than 2, you will start from the 0 over here. You see on the number line, I have highlighted in the green color a 0. Okay. Now we need to think x is greater than or equal to 2. Not equal to. The equality is not mentioned over here. It's just greater than. So how will you plot it on the number line? That's what we're going to discuss now. Easily, I will give you simply one way that you can think directly on the number line, and you can go to the Desmos also and plot. Absolute value, distance greater than 2. That means the distance should be 2 points away from 0. Distance should be 2 points away from 0, and I will use this 2 and negative 2. When it's a distance, should it be positive or negative? What do you think? Whenever we are discussing about distance, remember I gave you an example. So if I'm standing over here, the distance from me to the wall will never be negative. It's always positive. There is no direction in this. No direction, distance is always positive. So it doesn't matter if I'm going to the left or to the right from the 0, the distance will be positively increasing. And that's why we mention it with an absolute. And when we are saying distance is greater than 2, that means we must have to be 2 points away from 0. And if I will highlight that distance here, how will that be done? You see, this blue highlighted thing, that's the shaded region. And how far can it go? How far can it be greater than 2? What do you think? How far can it be greater than 2? Infinite, infinitely greater. It can go all the way to the positive infinity or towards the negative infinity. That's how you will mention it. Easy? Then after that, if it's the other way around, like if you will check the other inequality over here, that's in flip way, like x absolute in that one is less than 3. That means the distance from 0 in that specific case must be less than 3. Okay, so let's highlight here on this number line also, where is the 3? 1, 2, 3 over here, and the negative side, this is a negative 3. And we are saying the distance must remain within these two limits. Then what will I do? I will highlight the area or the number line, what the area obviously, number line between these 2 points only. In both of these cases, do you see equality sign along with the inequality? It's not less than or equal to, it's not greater than or equal to, it's just less than or greater than. In such cases, I will suggest you to put the parentheses here. Parentheses on both sides. Here. And if we have noticed, on the left-hand side, there are two intervals that we have highlighted. Agree? But on the right-hand side, there is only one interval. In both the cases, I have used the parentheses, not the brackets. That's the key point. That is the only key point that you're going to use over here. Is this absolute expression isolated already? Remember, when we were solving the absolute equations, we decided that we will first make it sure that the expressions are isolated, and then we will go for the split of the equation. Here, I will ask you again, what do you think about the yellow highlighted? Oh my God, I need to highlight it in yellow. What do you think about the yellow highlighted expression in both the cases? Do you think that this is isolated? There is no multiple, there is no addition or subtraction to the yellow highlighted term. That means it's isolated. Okay? And that tells me the center of the absolute function, if it's plotted, the vertex should be on the y-axis. It's not going left, it's not going right the way we have checked the transformations. It's staying on the right. So absolute expressions, if I will check the next ones, let me take you here. Question number 1, 2, and 3. Now I will discuss a little bit few more words which are here and or. It's clearly saying that if you have the less than, you will normally be using and if you have more than where your result is split, you can take the or also, but normally you will be using the and word only between the different inequalities. We will show you how to do that. Now here it was the thing that I was telling you, it's not going to be difficult, not too much of thinking. I'm making it easier. I know that we have practiced the equations already. So we will use Desmos here. Let's bring in Desmos. What we are going to do here, your example 1, let's type in the result there. Now, x plus 6, this is the first one. We enclosed the absolute lines. And then after that is less than, you see over here, if I have not mentioned the inequality, it's plotted as a function, absolute function. We know about that. Now what's happening, as soon as I will bring in the inequality here, what happened? Let's see. What happened? The function now is shaded region. It's telling us the whole of that region where this inequality is true. Think about that. X plus 6 is less than 3 in this case. If you will try to take this n side limit, what is that? -9. Let me zoom it in a little bit up till here. So this is a -9. -9 plus 6 is what? -3. So it's less than 3, obviously. If you will take it from here, -3 plus 6 is going to be a 3. But that's equal to 3. And the reason this line is dashed is because 3 is not inclusive here. 3 is not inclusive here. Let me show you one thing here. If I will type in, keep an eye on the graph. If I will type in here, along with the inequality and equality also, what did change? The lines are downward dashed. Now the lines are solid. That means this line is included in the shaded region. I can simply backspace from there, equality is gone. Now the lines are again dashed. So in this case, lines are not included. Make sense? Let's bring this thing over here on the number line. You just notice, I will suggest you to consider that this number line is giving you the limits, those limits which we have just seen as highlighted limits between -3 and a -9, right? Got it? Were these the limits that we saw there? -3 and -9? We will use those same things over here. And then which area was highlighted? In between or outside? In between. So we will highlight the area in between over here also, and we are done. But one thing remaining, I need to mention my answer also. How will I do that? Key point, thumbs rule. Look at this. Do we have equality here? We don't have equality, it's just an unequal sign. So what will I do? Should I use the parentheses or the brackets? We will use parentheses here, okay? And parentheses are there, the values are there. That's going to be my resulting interval, and I will mention it here from -9 up till -3 is my answer for this inequality. Make sense? Little bit? Let's do one more example from here. Example 2. What's different? What is different in example 1 and example 2? In case of example 2, we have the equality also. How will that change the whole scenario? Let's look at that. I will take that also in Desmos, plot it there, and see what's the result. Let's do it. You don't need to remove the previous one. What you can do, you can always click on this dot that will hide the plot. And then you can add your next inequality, which is what? Pi, absolute line of x. And then after that, minus 3. You see the plot is already taking its shape over there. But we are not gonna stop here because we need to complete the inequality, and that's going to be greater than sign. And look at this. After the greater sign, if you will on your keyboard press the equality sign, that's how you will bring the line below that. Or you can use the keyboard from Desmos. This keyboard directly gives you the access to the less than and equal. Both ways you can put the equality along with an inequality over there. Now, I will put a 17 there, and you see there is a shaded region. What's different on the limits or the boundaries of this shaded region? I'm just trying to zoom in to bring the whole thing in the picture. What do you think? What is different here in this shaded region? The lines are, first of all, it's split on both sides, and then the lines are not dashed. You see, if I will bring the previous one in here, the line here was dotted, the dashed line. Now we have solid lines in the blue region. We will plot this same thing over here on our number line. What were the limits? The limits are 4 and -4. What will I do? I will now highlight the region to the left of -4 and to the right of +4. What I'm going to mention here, a -4 here and a 4 here, making it show that we have a -4 and a 4. Yes, we have it. Same thing. Now, key point. Do we have the inequality or less than or equal or greater than equal? Equality is there. What should I use? Parentheses or the brackets? Brackets, good. So I will put here the brackets like this. I will use the brackets there. Got it? Makes sense? Then look at this one more point here. Whenever we have the less than, inequality contains these things, like we had it over here in this region. The region is similar over there. It's kind of an and. Here it's split. So what should we use here? We should use there an or. So what will I put here? First of all, I need to think that I have two different intervals. One is from -infinity to 4, and that's what I will put here. Be careful here, don't miss it. Don't miss it. With the 4, I will use the brackets, but with the -infinity, I will definitely use the parentheses. Then after that, with the word or, what will I use? I will put there brackets, and then I will put there from 4 to +infinity. Keep it in mind, on the right hand side, it's always up till infinity. On the left hand side, it's always up till -infinity if the outer region is shaded. If the interior, the internal region is shaded, inside region, then you will not bring in the infinities. Like in this case, we didn't bring in the infinities, we just put the limits because the region was shaded inside. Here, the outer region on both sides is shaded, so we will always bring the -infinity and infinity over there. With which word? The word that you will bring in over here is or, not the and. Not to put the and over there, keep it in mind, and connect it with the statements also over there. We have the two examples. Now, is it difficult? Plotting it in Desmos, easily done. You can solve it also step by step, but I will keep that for later. At this time, just keep on bringing the results there. Now tell me which one should I solve for you? From here or from the other side, whichever you will tell. Number 4. Okay. So number 4, let's do the number 4 now. Here, I will do the same thing. Let me work in Desmos. I will hide the area which was there before by clicking on this circle. Then I will type in the number 4, which is an absolute line, 2x. Oh, where did that go? Here. Absolute line. Okay, I messed up a little bit, but okay. I'm bringing it back on the Desmos. So absolute line 2x minus 1, another absolute line, and then after that plus 4, and that's greater than 3. You see the shaded region? How far is it shaded? All the way? Any limits? No bounds? Is that why you told me to do that? Good. There can be two possibilities. Either this, that you see all the region shaded. The other possibility can be nothing shaded. Nothing shaded will happen when there is no solution. Remember?
I figured that, but I wasn't sure, so I wasn't sure before.
Okay, it's a good choice. Like if you brought it to me, I'm generally sharing with this, along with this. You may face another case. Okay, what's the other case? You see here, everything shaded. The other case will be nothing will be shaded. So when nothing is shaded, what will you say? You will say no solution. And if everything is shaded, then how will you put the result over here? Let me show you. I will take you back over here on your result sheet, on your example sheet. Where is it? Number 4. We just noticed this, that here, everything is shaded from where to where? From negative infinity to positive infinity. So what will I do? I will also highlight everything. The complete area will be shaded for views. What does that mean? What should be the interval now? Can anyone tell me? Say again. No solution? No solution is the case when nothing is shaded. Here, everything is shaded. So what should be my result? How should I mention the interval?
Would you write negative infinity?
Perfect. That's what I will write over here. Perfect. That's what I was waiting for. Good job. From negative infinity to positive infinity, that's what we will write. That's our answer. Make sense? Is it difficult? Take the question, write it down over here in Desmos, bring it back over here, shape the region, write your answer. That's what you will do for rest of the questions. And let's see, what do we have there? You can solve this also yourself. Nothing difficult. Plot it over there in Desmos and see which region is shaded and then do it. Number 3, you can do it yourself. Let me check quickly. Yes, look at this. Number 6 here. This is the one that I was telling you. Jada? This is the one that I was telling you that it may not have anything shaded. Can you try the number 6 in your Desmos and see if it's giving you any shaded region? Number 6. Try it in your Desmos and tell me if it's giving you any shaded region. I will also try it along with you. I will first remove this. And we are done.
It doesn't have nothing.
It doesn't have nothing?
Like nothing shaded.
Nothing shaded. Okay. What do we mean by that?
No solution.
No solution. Good. Can you tell me the reason? Nothing shaded, we see?
Yeah.
So what's the reason? We have discussed this reason in the absolute equations. Remember, Alexander? Do you remember what's the solution? Like, what's the reason why nothing is shaded here in the case of number 6? Huh? Because there is no solution. And why there is no solution? Nothing is shaded. Okay, listen. I will tell you the reason. Look at this. Did you notice the negative sign? Can absolute value be negative? Absolute value cannot be negative, but what is it saying to us? It's telling us that absolute is less than negative. That will not happen. That's the reason it's no solution. So you will simply write down over here, if you will see an isolated absolute expression and it's equal to or less than or equal to the negative number, you will simply claim no solution. So that's how you will solve rest of the questions also. I will stop the recording now. That's